Welcome back to Chem Quiz online class. Good to have you here. We are going to look at what chemical kinetics are going to be a video series. So, under this chemical kinetics, look at what we are going to look at here. Rate of reaction. We are talking about introduction, the average rate of reaction flowers to stoichiometry is very important here. They want to look at rate loss order of what reaction. I can use the rate law to calculate what the rate constant and what the order of what of the reaction. They want to look at what the zero life, so the zero order reaction, the first order reaction, and what second order reaction. After we have done that, we want to learn about fraction life of zero, first, and what second, which is what the fraction life we are going to concentrate on are what half life, one third, one fourth. They want to look at our collision theory, factors affecting the rate of reaction. So it's going to be a video series. So, but in this first video here, you want to look at what the first one. The first one I want to what look at. It's okay. So in my later on videos, you have to look at this other one here. Now, one thing about my video is that I will use a particular video can explain a concept in detail. So that by the time you finish watching this video here, you'll be able to solve all questions relating to this guy. So it's going to be an interactive class and a calculation class. So I want you guys to be with your I want you to be with your pen, your calculator, and your notebook to take down every single thing. Don't procrastinate this video that you're going to watch it later. Follow up the class now. Take down every single thing. If this video is helpful, please only leave at the comment section that this video is helpful and make it to understand. Do you get that? It tells me that you're actually following this video and this video is helping you getting or understanding this topic. If you have anybody that's supposed to join this online class, kindly inform the person that they should join this online class or copy the link to the word person. Do you get that? So let's get into it. Let's look at what this other one here. The study of the rate of chemical reaction is called chemical what? Kinetics. So now, if for example here we have a reaction A, which one is the reactor, move to what? To B. I mean, now how fast this reaction occurs to produce one here is called the rate of what? Of reaction. And the study of the rate of reaction is called chemical what? Kinetics. So when you are studying the rate of a reaction, there are two things you must put in mind. One, the concentration. Two, the what? The time it takes for the reaction. So if you compare the reaction between a matchstick, when you're burning a matchstick and a candlestick, and that matchstick burn faster than what candlestick. So the study of what of the rate of that reaction, how fast the reaction occur. So how fast the reaction occur, that's what we call rate of what of reaction. Do you get that? So it what depends on what concentration of the reactant and what time each what the reaction takes place. So it can occur very fast, so it can occur very slow, depending on the nature of what of the reactant or the what product that is being formed. We're going to talk about what reversible what reaction. So, but here when we're talking about rate of reaction, now we're talking about irreversible what reaction. So when a reactor moves to product, the product do not react back to form the reactor. It's called irreversible what reaction. That is, we have what only forward what arrow. So here we have the reactant, here we have what of what, here we have what the product. Now another thing you want to understand here is that as the reaction occurs, the concentration of the reactant tends to decrease, while the concentration of what of the product tends to increase as time elapses. So that is why it's that the rate of reaction depends on what two things here: concentration of the reactant and what time it takes for the reaction to occur. So in saying that, if you look at the rate is always equals to what? Concentration over what? Over time. It's okay. Concentration over what? Time. Now, and the unit of concentration is what? Is mole per what? dm cube, or you can say liter. And the unit of time is what? Is seconds. So here you can see that in the exam they will ask you what is the unit of the rate of a reaction. The unit of rate of reaction is what? Mole per what? dm cube per what seconds. So get the first two you want to put in your mind. The unit of what rate of reaction is always equal to what? Mole per dm cube per what seconds. Or you can say mole per liter per what? Per seconds. Do you understand? So that is what the unit of rate. Now, here you can see that the rate of a reaction is equal to what? The rate of disappearance of the what? Product of the reactant equals to what? The rate of appearance of the product. So you want to put this in mind. Rate equals to what? Rate of disappearance of what? Of reactants is equals to what? Rate of what? Appearance of what? Of products. And I will explain so you understand. Remember, at the initial time before the reaction occur, like burn of your what? Candles of your matchstick. Now we have more of the concentration of the reactant, right? Now immediately what the reaction takes place, or immediately what you light the fire, what will happen here? The concentration of the what? Reactant will start decreasing as time elapses. As the concentration of the reactant is decreasing, what happens? It starts forming what? Of what? The what? Product. So that is that the rate of reaction is equal to what? Rate of disappearance of the reactant is equal to what? Rate of appearance of what? Of the product. It means that as reactant decreases, product what? Increases. Do you understand? That is why I say disappearance of what? Of the reactant, appearance of what? Of the product. This is that. So if you should look at this reaction here, remember that rate is because of constitution over time, right? So you can write something like you can write mathematical what equation like this. Rates is equal to what? Concentration of what? Of A, change in concentration of A over what? Change in what? Change in time equals to change in concentration of B, which is what the product, all about change in what? In time. Just that. Now, but understand that the product, sorry, the reactant is decreasing while the product what? Is increasing. So to signify that the reactant is what? Is decreasing, you put what? A negative sign here. This negative sign have shown that the appearance of what? Of the reactant. Do you understand? So it's very, very important to indicate this here. Then for the product side, you're going to go positive. Now, this minus means what? Disappearance. This plus means what? Appearance. Do you understand now? So you want to put this in mind when you are calculating what? The rate of reaction. So here now, then we can look at two things here. Now we can either look at what? The average rate of the reaction. But before we look at the average rate, now let's draw a graph that shows this. Let's draw a graph that shows this. If, for example, you plot a graph, concentration, the square bracket means what? Concentration. Concentration over what? Time. I there. Now, we are using what? A moving to what? To B, right? So here we have 1, 5. Okay, here we have 1, 2, 3, 4, 5. So okay, let's look at this one. 1, 2, 3, 4, 5. And here we have this other one here. So let's say 0.5, 1, 1.5, 2, 2.5, 3. It's okay. So look at the time, which is what? Seconds. This is that. So if you plot the graph, you find that the concentration of the reactant tends to tends to decrease. It's okay. Now, as time elapses, the concentration of the reactant tends to decrease. Now, as the concentration of the reactant is decreasing, now the concentration of the product is also what? Increasing. Guys, see that? So here is what is the concentration of the reactant, which is what? A reactant. Now here is what? The product here. So this is a graph that explains the rate of what? of reaction. Do you get that? So you have to what takes on down, so that you get. So the next one I want to look at is what is the average rate of reaction. That is what that is first one I want to look at. Calculation of what of the average rate of reaction. Calculation of what average rate of what of reaction. So when we talk about average rate, you're talking about what final minus what initial. Do you see that? So average rates, average average what rates. So now we are still using this one here. A moving to what to B. So if you look at this one here, it means that minus change your constitution of what of A over what change your constitution of change what in time. This that. So this one here, when we talk about change, you know we have what we call final concentration, the what initial what concentration. This is that. So this one means what for final concentration. Here we have what initial what concentration, right? So if you input there, it's going to be minus bracket up here. Here we have final concentration of A minus initial concentration of A over what change final time is what initial what time. You see that it's very very important here. So this one you are seeing here is this guy final minus what initial, right? Then this one is what the final time minus what initial time. Now this is where we are for what for the reactant for the what reactant. If you talk about the product here, my average rate average rate average what rate is going to be what plus change what in B over what change in time, right? We're also going to be the same type of plus final concentration of what of B, which is what the product, minus what final concentration of initial concentration of the B, which is the product over what over T2 minus what T1. But in this calculation here, you are actually what focusing on the word product is only the reactant you are going to focus on. So most of the questions we are going to look at in in this video here, and what you are going to see more is what is going to be the what for the product for the what reactant, not what the product. So how do we do calculation here? Let's solve one or two questions so that what you understand it. So I want to solve one question, then I want to try the next question. Do you understand? If you're ready, say you're ready, leave at the comment section that you are ready. I need this. If you understand what I've done so far here, say you understood and you're following up this video. If you don't still understand, you can leave your question at the comment section. Do you get that? So let's take some example. Let's look at our first question. Say calculate the average rate of a reaction between 30 and 20 seconds and solution of 40 between 30 from what from the what data. So here look at the reaction here. Look at what the reaction here. You can see that is only for the reaction that is irreversible what reaction. So this two we have to put on here, but this two cannot be added to put that one. Do you get? So it's called irreversible what reaction. Now we are picking one of the reactants, which is carbon monoxide, right? CO. Now you find that we have what from time 0, 10 seconds, 20 seconds, 30 seconds, and what 40 what seconds. Now at the initial concentration, which was 0 second when the reaction has not occurred, we have 0.100 concentration of what carbon monoxide. Now, but at 10 seconds, you can see that it has reduced to what 0.067, right? Then at 20 seconds, it has reduced to what 0.050, right? At 30 seconds, it has reduced to what 0.040, and at what 40 seconds, it has reduced to what 0.0333 concentration. So now they're asking what is the average rate. So we will calculate what is the average rate. Now, therefore, let's write our equation here. So here we're going to be rates, which is the average rate. You're going to go to now because we're talking about reactants. So going to be minus here. Change in concentration of carbon monoxide over what change what in time. This is that. Now, so when you talk about change, we're going to do what in final constitution minus what initial constitution. So if you should write that here, square brackets. Now the final constitution of carbon monoxide, right, which is T minus what initial constitution of carbon monoxide, which is what 0 here over what T2 minus what T1. This is that. So what you want to understand here is that COT is going to be what final what concentration, right? Then here we have CO naught. It's going to be what initial what concentration. Then we have T2 because of what final time. T1 equals to what initial what time. Right, that. So here we have the final constitution, initial constitution, final time, initial what time. So you have to take this down so that you understand what I'm doing here. So the first thing here I want to get, because it said that at 30 and what 20. So the first calculation here at 20 and what at 30 and what 20, then between what 30 and what 20 seconds, right? So for me now, my final time is what is 30 what seconds, right? Then my initial time is what 20 what seconds. Now, for my final time, I want to get my final concentration. So here going to be COT and what CO what not, right? So final time give me what final concentration. Initial time give me what initial what concentration. So let's trace at 30 seconds. Yeah, here is what 30 what seconds here. My 20 seconds, the concentration is what 0.040. So that's my final concentration here is going to be what 0.040 mole per what dm cube. Can you see that? Then at my initial concentration, which was 20. So initial time 20. What is the concentration? The concentration is 0.050. So you have 0.050 mole per what dm cube. Can you see that? So from here, I can easily calculate what the average rate. So you can say the rate equals to what minus. Now my final time is what 0.040 minus initial is what 0.050. Here we have mole per what dm cube over. Now my time is going to be what 30 minus what 20. Can you see that? So what I want to do here is so what reduce the calculator to what punch your answer 0.040 minus 0.050. Now divide by 30 minus what 10. So you have to do that calculation. So if you should do the calculation here, so that is why I say you what get out your calculation. So please leave your answer in the comment section. What is the what first one? What is the answer? Leave it in the comment section. So what is the answer here? So you have 0.040 minus 0.050, right? Which is so going to give me minus. Remember, there's minus here, right? This minus is going to give me minus 0.01, right? Over what? 30 minus 20. Here we have 10. Minus times minus is what is plus, right? So going to be plus 0.01 divided by 10. So what is the answer here? So you have 1 times 10 to minus 3, right? Now, that is my average rate between 30 and 20 is what? 1 exponential minus 3. But what is the unit of the rate? What is the unit of rate? The unit of rate is what is mole per dm cube per second. So it's going to be mole per dm cube per second. That is the what answer. Do you see that? So you can see I is it is to what to calculate what the average rate from what from the experimental what table or for the what table given to you. So if you look at the second one, let me write this place here. Let's look at what the next one between 40 and what 30. So that is my final time. My final time is going to be what 40 seconds. Then my initial time is going to be what 30 seconds. Can you see that? Now, for my final time, I want to get my final concentration, which is what concentration of T, right? So we're going to be at 40 seconds. Let's show 40 seconds. Here I have 0.033. 0.033 mole per what dm cube, mole per what dm cube, right? Now, the same here, my initial concentration 30 is giving me what 0.040 mole per what dm cube. This is that. So from here now, let's look at what the average rate, the average rate equals to. So minus, right? So my final concentration is what 0.033, 0.033 minus 0.040 over here would be what 40 minus what 30. Can you see that? So what happened here? We have minus this. So you have 0.033 minus 0.040, right? So which give me minus 0.007 over when you subtract on your 40 minus 30, here we have what 10. Remember, the unit of this one here is what mole per what dm cube. Right here we have what seconds. Can you see that? So minus times minus one is plus, right? So going to be 0.007 mole per what dm cube over what 10 seconds. So what happened here? 0.007 divided by 10. Here we have. So it's going to be 7 times 10 to the minus 4, right? Minus 4 mole per dm cube per what? Per second. So the average rate between 40 and what 30 is what 7 exponential minus 4 mole per dm cube per what per second. So I would like you all to try the average rate. So the average rate between so what I want to do here, pause the video and solve the average rate between 10 and 0. So go ahead, solve the average rate between what 10 and 0. So what is the average rate between 10 and 0? I just ask you what is the average rate between 40 and 10? What is the average rate between what 40 and what and 10 seconds? So go ahead and try between 40 and 10 what seconds. So go ahead and try this too. Between 10 and 0 and between what 40 and what 10 seconds. So go ahead, try it. So you can send me your answer in our private group. You get that in our WhatsApp group, our interactive group. So now for those of you who don't really understand, who don't really know, we have an interactive class after this online class on this YouTube class. We also have our general community class. You get a group, WhatsApp group community. We also answer questions. Now, but before we continue here, I will advise you to get a copy of my book here. A copy of my book is very important. It's called Principle of General Chemistry 2. It contains most of the stuff you are going to do in your second semester. Like in this first semester, I contain everything here. I'm going to list the topics that's being covered in this book. So it's very important. So if you're my student, after this class here, you tell me that you need a copy of this book. Now, one of the advantages of you being in this online class here is that once you're my student in this online class, then you have enough privilege about my physical class. So for those of you who are very, very active in this online class, you have a special bonus here for getting this book. So like what I said here too, this is called the organic chemistry. So these two books are very important for you to get. It explains everything. Imagine if I can teach you like this. Imagine the enough time I put to go to do this book here. So make sure you get a copy for yourself. It's for your personal study. Now, one thing that will help in your personal study is your private. Now, is the book you use. Most times, the book we use does not actually want to communicate the information to us very well, and it's a little bit boring. So, but with what I know with chemistry, I'll be able to put all this material together. So try and get a copy for yourself. The link will be at the description below. That explain everything and topics that there's going to cover. So go ahead and solve this one for me. So this is all about the average rate of what of reaction. In our private group, you are still going to solve more problems. The next one to look at now is what rate of reaction and stoichiometry is very important. This one just what rate of reaction. So let's look at what rate of reaction and stoichiometry calculation. Move over to the next thing, which is what rate of reaction slash stoichiometry, and this is the main focus of this class. So you have to pay close attention. Now, you see question on the board. Say it was observed during the what decomposition reaction of ammonia that hydrogen was being formed at the rate of 0.062 mole per liter per seconds. Now, this is what is the rate, right? Now, this is what the decomposition of ammonia. When you decompose ammonia, you're going to form nitrogen gas and what hydrogen gas. Here's what balance equation. Now they're asking calculate the rate of decomposition of what ammonia at the time observed. Calculate the rate of formation of the rate of formation of what nitrogen gas at the time observed. Then calculate what the rate reaction at the time observed. This is a is one type of questions you can never escape when it comes to what chemical kinetics, when it comes to what rate of reaction. So you're going to pay close attention to what I want to explain to you here. But first, let me explain the background for you. So remember, I said that the rate of a reaction when atom like this A moving toward to B, right? Now, the rate of disappearance of A, which is reactant, is also rate of appearance of B, which is what the product, right? And we from the rates here we have what minus change in concentration of A or change what in time equals to plus change in concentration of B or what change in time, right? Now for the first one we did. Now this is just normal what reaction. Now what about if you have what a general reaction? If for example here we have A plus B giving what C plus what D. Now this is a general what reaction here. So how do you write the rate of reaction here? Remember here the coefficient are what 1 1, so we didn't really what bother. So from here now we calculate what the average rate of what of the reaction, right? So which what the final concentration minus what initial concentration or what final time minus what initial time, where we do those calculations. You remember, right? Now, but this one is different. If for example now they ask now to write the rate of reaction for this, the rate equation for this reaction here. Now you can see that they are all having what coefficients. Here we have two products. So here we have two reactants and two products with our various what coefficients, right? It means that before you do this one here, you need to what write the balanced chemical equation, just like what we did here. Do you understand? So if you want to write the rate of reaction, you're going to be rates is equals what minus, right? Because these two are the reactant, and reactant tends to what to decrease, which is what minus. So going to be minus 1 over A. Now 1 over what A, which is what the coefficient, which is what constitution of A, what constitution of what of T, right? So this is what the rate of what of A of this A here. This one is what coefficient. This is that equals to. Now we also have what we also have the reactant here, which is what B. So it would be minus 1 over B concentration of B, change concentration of B over what change what in time. Can you see that? Then equals to. Now I am done with my reactant. So I'm now moving over to the product. Remember, and I'm moving over to the products. As these two reacts, what happens? They start decrease. Therefore, we have minus here, as as we move to the product test what increase. So we have to add plus one about C change in consideration of C about change in time. Can you see that? Equals what plus one over what D change in consideration of D over what change in time. Now, what I want you to understand here is that remember rate is only because of what change in what concentration over what time, right? Now, if you want to write change A over change in time, so you can just say rate A. So here you can see that rate is equal to minus 1 over what A, rate A. Can you see that? Now, the reason why I say rate A, remember that concentration all over time is what is rate, right? And I'm talking about the first, which is what the A. So instead of writing also here, I can just say rate A, right? Equals to minus 1 over B rate B. That's that. So this rate B is also the same thing as this guy here. Equals to plus 1 over C rate C. Can you see that? Equals to what plus 1 over D rate what D. Now, what I want you to understand is that this guy is the same thing with this other one here. Do you understand? So this is just a way to now this is called the general what equation. How to write the rate of reaction for what general what reaction. You just that. So with this one now, they can ask you so many questions. So you have to put this thing down. Put this thing down. If you are following, please leave in the comment section that you are following. Please, I don't need understand here that I don't need ghosts. I don't need ghost students here. I need active students. So if you actually understand this here, please leave at the comment section that you understand what you are doing here. It's very important. Please let's make this class interactive. Let's make this class what interactive. If you are new here and you have not subscribed to the channel, please hit that subscribe button and turn on the notification bell so that you are not going to miss out every other content we are going to drop on this channel. It's very important. Please, the only way you can support and grow this channel is your like, your comments, just that. So I really need those things. It helps to boost the algorithm. It's very important. And this is what I'm asking of you. Especially if this channel is helping you, chemistry is helping you. And another way you can support the channel is by telling your friends about chemistry TV that they should join our online class. This is called pure online class. So in the sense that at the comfort of your home, you can easily learn from the comfort of your home. So that is answers. So if this video is really helping you, please leave at the comment section that this video is helping you and you are great for that. So okay now. So let's move over to proper question. Now let's look at this reaction here. Let's look at this reaction. So this is a balanced reaction. So let's look at the general reaction. If you want to write the general rate of the reaction, because I talk about the rate of reaction is like what stoichiometry. So in stoichiometry, we use what the balance coefficient. This that. So it's going to be rate. Rate is equals to what? Now you have 2 here, so going to be minus 1 or 2. Can you see that? Change in concentration of A or change in time. Now the main reason why there is minus here because is what is the product, and the coefficient is what is 2, so going to be 1 over 2 equals 2. Now we also have a reactant here, so going to be minus 1 over 3 change in concentration of C of C over change in in time. Can you see that? Equals 2. Now you're going to be plus 1 over 5 change in concentration of D over change in time equals to what? Plus 1 over 4 change in concentration of P over change in time. Now, to break things down for you, you can just say minus 1 over 2 rate what? A. Can you see that? Equals what? Minus 1 over 3 rate what? C. Then equals to what? Plus 1 over 5 rate what? D. Then equals to what? Plus 1 over 4 rate what? P. Now it's still the same here. Now in the exam, they can give you in different formats. Now, like I ask here. Now they'll give it with different options because this. So there are different ways you can equate it here. You can see that minus 1 over 2 rate A is equals to what? Minus 1 over 3 rate what? C, column. Now you can also say minus 1 over 2 rate A is equals to what? Plus 1 over 5 rate D. Guys, that column, here you can say minus 1 over what? 3 rate what? C is equals to what? Plus 1 over 4 rate what? P. So it can be anyone here depending on the type of question you are being what giving. Depending on what type of question you are what be giving here. So now once you have something like this, a different question will begin to you, which I'm going to show you now. I'm going to give you a proper what example there. This that hope you understand it. So instead that you can equate them. So you can also equate what plus 1 over 5 rate what D equals to what plus 1 over 4 rate what P. It's very important to know this here. Now I don't want to confuse more. I will want us to what to move into a proper question so that you get the gist. Hope you understand. So let's look at question on this one here before we move to this question. So before I teach you how to solve this type of question. So let's go into it. Then look at this question here. Typical exam question. If you check your past question, you always see this type of question. And it's a little bit confusing. But I don't want to be confused for you, so pay close attention. It's that for the reaction A plus 2B give you 2C, the correct rate of reaction is. So they're asking here, what out of all this option here, which is what is the correct rate of reaction? So the first thing you want to do here is what write what the general what rate of reaction here. Then by if you want to write it here, you get A plus 2B give what 2C. It's very easy here. Here we have two reactants, here we have what one product, right? So you can see that rate is equals to what minus 1 over 1, right? Because the coefficient is 1, so they're not going to put 1 over 1. So you can just say change in concentration of A or change in time. Do you understand? So because here is 1, so it's going to be 1 over 1, right? Equal to. Now, B is also a reactant, so there will be a negative sign, which is what? Minus 1 over 2. Change the concentration of B or change in time. Can you start? Equal to. Now, you're not moving toward the product side, and the product side, you use the sign of what? Positive. So, it's going to be plus 1 over 2. Change the concentration of C or change in time. Can you see that? So, if you checkmate it very well, now, here you can have different options. So from here, now you have to look at if this is going to be correct. So from here now, look at the first one here. It says that A plus change concept of C or 2 change time. It corresponds to this guy here, right? This guy is this guy. Can you see that? Nice one. So it's correct. Equals what? Minus change concept A over change time. Now, this guy correspond to this guy. So from here now, that is, you can equate these two here. You can see that minus change in concentration of A or change in time equals to what? Plus 1 over 2 change in concentration of C or change in time, right? This guy is correct. So this one is what is correct. Then this option is also what correct, right? Good. So we are just confirm this option here, and this one corresponds to one of this one here, right? Hope you understand. Please, are you following? If you are following, please leave a comment section that you are actually following. Let's look at what the B part. Let's check if the B part is actually what correct. Let's check if the B part is actually what correct. So here we have minus change in what consider of D of A over change time. This guy corresponds to this guy, right? Nice one. Now, but look at this one here. Minus change consider of B over change time. Now, this guy is supposed to be this guy here. Now, but here it's minus 1 over 2. But here is what 1 over 1. So this option is not correct. Hope you understand. Because checking this guy corresponds to this guy other guy here. Because minus change consider of A over change time equals to. Now here is supposed to be minus 1 over 2, but here got to be 1 by 1. So this one is not correct. Hope you understand now. So that option is not correct. Let's look at this one here, C. Let's see if C is correct. Now, look at this one here. This and this equals to what? Equals to equals to what? This. Now, this guy is supposed to correspond with this guy here. This guy is supposed to be correspond to each other. This one is totally what's wrong. This one is totally what's wrong. Just stand up. Totally what's wrong. Does not what match. What about this one here? Here we have minus c. Here is not minus, and here is what one all over two. So this guy is what is wrong. So the correct option is what is the A. Just so there are different ways they can ask the question in the what exam. So you need what you need to what study for that one here. As move on, we are going to solve more example. Do you get that? We are going to what solve more example. But now let me give you one question so that you answer. Let me give you one question so that you try it under this one. So what I want to do here is so what pause the video or copy inside your note and try it for me. This is what you have to do here. Which of these is the correct option? Is it A, B, C, or D? If I go to your answer, you can also leave it at the comment section. I will respond to that. You get that? I will respond to that. Leave it at the comment section. You get that? Leave it at what? At the comment section. Which is what is the correct option? So that is for this other one here. I believe you have not got a proper foundation on how to what to do this thing here. So the next thing you want to move to is this question. So let's see how you can tackle this question. Here we say it was observed during the decomposition of reaction of ammonia that hydrogen was being formed at the rate of 0.062 mole per liter per watt seconds. So here is what is the equation here. Very important. You write for NH3 giving you what? N2 plus what? 3H2, right? So the first one we want to do here, before we stop anything, let's write what the rate of reaction. Let's write what the rate of reaction. So if you write the rate of reaction, here we have rates. So you can pause the video and write for me, pause the video and try this for me. Write it down. See if you're going to get the answer. Pause the video. So going to be minus 1 over 2 change in constitution of NH3 or change in time, right? Now, the main reason why there's minus here because what is the reactor is decomposed to form these two things here. And the coefficient is what is 2, so going to be 1 over 2 minus 1 over 2 change constitution of the ammonia or change in time equals to. Now, I only have one reactant here, but I have two products here. So here are going to be plus. So there's no coefficient here. The coefficient is 1, so it can be change in constitution of what N2 or change what in time. Can you see that? Equal to, here we have plus 1 over 3 change in constitution of H2 or change in time. Can you see that? Now, this is what rate of reaction. Do you see that? This was the rate of reaction. Now, if you look at the question here, look at something here. Now, the question is going to determine if it's going to be negative or positive. Now, there are two things you want to take note here. You have decomposition. Now, whenever you add decomposition, now what should come to your mind is what is negative. What should come to your mind is what is negative. If the rate of decomposition, now if the rate of a species is decomposing, that is decreasing. Do you understand? So if I see that the rate of decomposition of A, is equal to what 0.025 mole per liter per watt seconds. Now, what should be in your mind is that the rate is going to be what? Now, because they say decomposition. Understand this here. Decomposition. Decomposition means what? Decreasing. So it means that you must introduce what a negative form here, a negative sign here, which is going to be minus 0.025 mole per liter per seconds. That makes sense here. But what about they say formation? When they say formation, right? Formation is what is positive. Is what? It's positive. Now they say formation of A. Now decomposition is always what the reactant. Do you get that? Formation is always what the product. Understand these two things here because these things are key for you to understand how to tackle this kind of problem here. So decomposition, what should come to your mind is what is the reactant. Formation is what is the product. And formation will always be what? Formation will always be what? Positive. 0.25 mole per liter per second. You see that? So with this said, this is what we want to do here. Now, if you look at it very well, this guy is decomposing. So the rate will always be negative. The rate will always be what? Negative. Is what is decomposing. Now, these two are forming, that is that the product, the rate is always what? Positive. Do you understand? Now, from the question given to me here, is that it was observed during the what decomposition reaction of ammonia, of what? Ammonia, that the hydrogen was being formed at the rate. So the rate, remember, I can write something like this: rate is equal to minus 1 over 2 rate NH2, right? Then understand this one is also the same thing with this guy here. Do you understand? Because change the construction all about change time is what is the rate. Do you understand? Equal to plus, give it, can say rate N2, can you see that? Equals to plus 1 about 3 rate what? H2. Now, in the question, they have already given me what the rate of formation of what? Of hydrogen gas. Look at it here. So from the question now, it says rate of formation of hydrogen gas is what? 0.062 mole per liter per second. So understand this here. Now, is it going to be positive or negative? Now, if I should ask you here, is it going to be positive or negative? Now, because the word is what is form, which is called formation, and is what is the product. Going to be what? Positive. Going to be what? Positive. So then, this one I've already will be given to me. This is what you really want to understand here. Now, look at the first question here. Yes. It says calculate the rate of decomposition of what? NH3 at the time observed. Now, from this further one here, we can get what? The rate of decomposition of what? Of ammonia. We can also get the rate of formation of what? Of N2. Do you understand now? So from this value given to me, I can get this guy, I can want to get this guy. So for me to do that here, so I can write this. So let me write this place here. Now, because I'm calculating what the decomposition of what of NH3 here. I'm calculating what the decomposition of NH3 here. So what am I going to do now? I'm going to relate this guy with this one here. I'm going to say using minus 1 over 2 rate what NH3. This is that equals to plus 1 over 3 rate what H what 3. Can you see that? H what rate what H2. Now, do you know the reason why? I know this one here. I'm looking for this guy, so I can easily what relate the two of them. Minus 1 over 2 rate what NH3 equals what plus 1 over 3 rate what H2. Can you see that? Now, remember this one I've already been given to me in the question. So from the calculation here, I'm now saying minus 1 over 2 rate what NH3 equals to what plus 1 over 3 times. Can you see that? Times. I will now include this guy here. So for now, I will leave the what the units. So I can just say 0.0 what 62. Can you see that? So what I want to do here, so what grab my calculator and do the calculation. So here I can just say rate NH3 here minus over what 2. Can you see that? 2, because 1 times 1 is this over what 2 here equals to. Now if I should do the calculation, 1 times this divided by 3. 0.062 over what 2, right? So if you do that here, you have minus what arrow NH3 over 2 equals to, you have 0.02067. Can you see that? So please for me, so I want to write this one here because this is what we are calculating. Sorry, I have to write all these things. So now, if I should make this one instead of formula here, I'm going to work cross multiply, right? If I should cross multiply here, I have what minus RNH3 equals to what? 0.02067 times 2, right? So if you should punch your calculator here, 0.0413. But you eliminate this sign here, what will happen here? Or multiply through by what? Minus 1 here. So here I have RNH3 is equals to what? Minus 0.0431 what? 3 mole per liter per watt per second here. So you can see that the rate of decomposition of what ammonia is what minus 0.0413 mole per liter per second. Now, one thing you want to understand here that this negative sign means what decomposition. Is okay, decomposition. Ammonia will always what decompose. Do you get that? It's always what decreasing. So that's why we have a negative sign here. So it's going to be minus 0.0413 mole per liter per what seconds. Do you understand? So that is it for the first one. There was for the first one. Now, B, you say calculate the rate of formation of what? Of N2. Now, the rate of formation of what? Of N2. Same here, I'm going to write this place. So we are going for this one here, right? So this guy, so we should what? Write this as somewhere here. So you can say rate NH3 is what? 0.041. Right? So this is so we have to keep it. We have to want to keep it because I'm still going to make use of it later. So now let's look at what for the B. You say calculate the rate of formation of N2. So you say that you're going to equate this guy and this guy. Now remember when we calculated NH3, the rate of NH3 here, we equated this guy and this guy here, right? Now we're going to equate these two things here. So you're going to be plus what? RN2 is equals to what? Plus 1/3 RH2, right? Remember, you already know this one here, so it's very easy here. This one is going to is very easy more than the other one we have done. So it's going to be so they're not putting the positive sign here. So it's going to be 1/3 times 0.062, right? So what we get here now is 0.0207 mole per liter per watt per second. So that is it. So my RN2 is what? 0.0207 mole per watt liter per watt per second. So this is the what answer. Can you see that? Now look at the C part. If you look at the C part, if you look at the C part, look at the word C part, say calculate the rate of reaction at the time. So he's saying that the answer is calculate the rate of the reaction, the entire what reaction. That's that the rate of the entire reaction. So that's what they are trying to what say she wants calculate for the C. Now we already know the rate of what of ammonia. We already know the rate of soil here. We already know the rate of soil here. Now, what will be the rate of the entire what reaction? Because the rate of the entire reaction must be the same. Just must be what the same. So if we should like impute our values here, so here you can see that the rate now we are looking for is equals to what? Minus 1/2, right? Remember this one is here, minus 1/2, right? What is NH3? NH3 is what? 0.014. So so we're going to do what? Minus because it's decomposed here. So it will be minus 0.0413, right? Do you understand? So now this one here is this one equals to plus this guy. I want to calculate this guy to be what? 0.0207. So here we have 0.0207. Can you see that? Equal to plus 1/3 times this guy is what 0.062 is okay. So let's do our calculation. Plus times minus is going to be giving plus, right? So let's do the calculation here. That is this guy is going to divide this one here. So it's going to be 0.0 206. Can you see that? Equals to this one here is going to be plus 0.020 what? Now when you approximate this one here, if you approximate this one here, it's going to be what? 7. It's okay. So here we have 7 here equals to what? Now when this one here we have 0.062 divided by what? By 3. So here we have plus 0.0207. This is that. So it means that the rate of the reaction, the rate, rate of the reaction is okay. Let me write all this so you don't be confused. The rate of the reaction is equal to plus 0.0207 mole per liter per watt per second. It's very important here. So you can see that with this question here, we are calculating what the rate of what of NH3, we are calculating what the rate of what N2. Now, if you find that the sign of ammonia is negative, now the main reason why it's negative is because what it's always decreasing. I find that when you calculate this one here, the sign is positive. And the main reason why it's positive because it's always what increasing. Now, but in general, the overall rate of the reaction, this must be equal to this guy, and this must be equal to this guy here. So that's why you see that rate equals to what minus this of this one here is equals to what plus this of this one here. Do you understand? So these are to do the calculation. So what I want you to do here is that I will drop a question on the board. Then, because my video is that by the time you finish the video, it should explain the whole of the concept for you. So that is the essence of this one here. So the next thing I want to do is what I will drop a question on the board. Then you have to attempt that question. You have to do what? Attempt that question. It's very important. So I'm going to leave you with a question you have to try for me. Do you get that? So they say calculate the rate of the composition of ozone if the rate of formation of oxygen is what 0.0055 mole per liter per watt seconds. So look at the equation here. It doesn't say what is the rate of reaction. So it's what you have done. As a matter of fact, this one is a little bit easier than the one we have done. So go ahead, try this one for me. Now, if you are in our community, online community, now you can leave your answer at that community. But if you have solved your answer, if you have solved it here, you can also leave it at the comment section. And if this video is helpful, please don't forget to give it a like. It's very important. And don't forget to subscribe if you have not done that. It's very important. If there's anyone you want to join, you wanted to know about this Chemicals TV, please go ahead, inform them that there's a channel, there's a Chemicals TV channel that is going to help them understand chemistry faster and better. So the purpose of this one here, the purpose of this year is so even when you are at home, you can also learn what you are supposed to learn. Do you get that? Now, very soon I will make a big announcement. I will also create a course, a video course, so that you can also get it for yourself. Where that course contains everything you are doing on this course here. We take what organic chemistry, inorganic chemistry, the calculation aspect of chemistry. It's very important you stick to this channel. And like what I say, if you have not subscribed, please make sure you subscribe. And let's always interact. Yeah, it's very important. You are my fan. You are the part of the family, and you are what part of the growth of this channel. Do you get that? You are part of it. So I want you to see that you are part of what I am doing here. Without you, there's no way I can be here. Do you get that? I cannot just start creating content for nobody. I'm creating content for you, and I want you to interact with me. And the only way I can do that here is by that comment section here from you. If this video is helpful, please leave at the comment section that this video is helpful. And if you understand all what you have done in this video, please leave at the comment section that you clearly understand. Probably if you have any question, you can also leave it at the comment section. Thanks for watching. You can see on the screen. We have some other videos popping up on the screen. You can pick any of them to continue your learning. But make sure you try this one here. It's very important. Thanks for watching. See you in the next video.